Hi everyone. Today I worked on a new mechanic for my game, Tiny Cosmos. I had the idea last night that it would be really cool to have a mini-boss where there's cargo containers that cranes throw at the player. This would play into a theme that I have for my stage, which revolves around mining and facilities where the ore is processed. So I wanted to share how I did it so that any developers that want to implement something similar in their game can do so. So this tutorial will be a little bit heady, but we'll get into how it was all made because it actually ended up being a lot simpler than I thought. What it looks like is essentially some pixel art assets that I threw together today with this base where there would be multiple phases in this boss fight. But the first phase is these cranes and some turrets. So what happens is you have these cores which start out closed. The player comes into the scene and these will open, but only after the player gets in close. These cores are actually tied to the controls of these cranes, or will be. These cranes pick up these containers and throw them at the player. Pretty cool. So as you can see, it'll move. The carriage will rotate or move along the arm of the crane, and then it will do a little backswing before throwing the object at the player. So how this is done requires some steps. And I really thought it was going to be a lot more complicated than it ended up being. So let's dive into it and I'll show you how it's done. I started my crane controller component with just these comments. We knew that the crane needed to find a container, choose a player target, rotate the crane towards the container, move the carriage towards the container, play the claw close animation, wait for an event for the animator to tell us that the claw had been closed, attach the container to the claw, rotate the arm to throw the container at the player, and then release the container, opening the claw, and actually launch the container. Which these are the last steps for this. So starting with just these comments, I created a coroutine, and I started with just voids for each one. Finding the container, finding the target, rotating the crane to the container, moving the carriage to the container, closing the claw, attaching the container, rotating the arm to throw it, and clearing the container. I turned each one of these into enumerators that were called within the coroutine as I needed to, but started with just voids. So first we find a container, which is a simple physics overlap circle. So what we do there is just basically just say that anything within the length of the crane's arm within the container layer mask, we iterate over all of those and we determine if we have a throwable interface that we've created, which tells us that we can throw the object. Then we compare the carriage transform, which is where the claw actually is, to the position, and the closest nearest distance to an object that meets that criteria becomes our new chosen throwable. If we have a throwable, we essentially disable the collider that we used to determine if it was an object that we could pick up. This prevents any sort of confusion between multiple cranes or even the same crane trying to grab the object it just thrown while it's flying through the air. We need to find a target to throw the container at. Here we just use our ship manager to get ships for the player team. But in your game, of course, you could use whatever reference or manager functionality that you might have. Essentially, you just need a position. So now we rotate the crane to the container to pick it up. So simply just getting the direction from the object that we are going to throw from our crane arms transform, we can get the rotation that we need to be at so that we can rotate towards that rotation. Pretty simple using rotate towards. and a rotation speed. Once that's complete, we're moving on to the move carriage to container. So this enumerator checks the distance to our target and our distance to the carriage current position, and then that will tell us which direction the carriage needs to actually move. So by using the absolute of that amount, we can determine if the amount we need to move is more than what we will actually move in a frame. And then we can use the sine of that travel based off of our carriage speed and our delta time to actually move the object along its local position. This prevents any sort of weird artifacts as the carriage moves down the arm of the crane. Then we just recalculate our variables using the same functions we did before. And when we're complete, we need to make sure that the last little bit of movement is spot on. So what we do there is essentially just get the carriage transforms parent, which just happens to be the arm of the crane. And then we can use inverse transform point to convert a world space position into the local position. We only need the x value of that position so that we can again just slide the carriage on the arm of the crane. With our carriage in the correct position to pick up the container, we can close the claw. So that's as simple as setting a Boolean so that we know that we're waiting for the claw to close, and we'll just watch for that Boolean to change in our coroutine until the animator's animation event has been called, which we'll call this onClawClosed function to reset the Boolean. That's pretty simple. Next, attaching the container is essentially just a matter of setting the rigid body on the container to a kinematic. And we take the parent of the object and we track that so that we can reset it later. We set the parent of the object we're picking up directly to the carriage so that it'll move as we move. And knowing that we are directly on top of where it needs to be, that's right where we want it to be. And there won't be any movement or any sort of rotational problems with kinematic physics, rigid body physics. So the fun part comes next, rotating the arm. So again, familiarly, we have the direction to target calculation and a rotation to face the target calculation. But now we're actually using the target that we want to throw it at. We need to do a backswing in case the rotation of the target where we would have the crane pointing currently is not far enough for us to pick up enough speed for it to look convincing. So we use this try-get backswing rotation function, which returns a true or false whether or not we actually need to do a backswing. And if we do, it will return through an out parameter the rotation that we need to use. And then we can just actually do that while we're not pointing in that direction. What this function looks like is essentially just getting the direction to the target, calculating its angle, and comparing the angle of the current angle and the angle to the target. So wherever the crane is currently pointing and where we need to go, and then comparing that angle. If that angle is greater than the backswing angle limit, then we don't need to do a backswing because we're already wider than that. But if we are within less than that in our angle, then we just need to add that amount to our angle and create a new rotation for that to return. Simpler than it seems. So then once that backswing is done, or it doesn't need to be done, we know that we can start to rotate. But before we do, we calculate an overshoot rotation. And the reason we do this is just for the rotation to look more natural. So what we're doing here is we are saying that we are going to overshoot the angle that we are throwing towards the player so that the crane arm passes 30 degrees further than pointing directly at the target. So with that, we can essentially just look at the rotation angle and use a smooth rotation from our current rotation to the new rotation. By smoothing the rotation, we get a more natural movement, specifically after we've passed the player direction, we can slow down smoothly. And that just looks a little bit more convincing. So how that is done is by using our current speed, starting at 0, because we just finished a backswing. We pass that in using a reference parameter, which allows this function to update the speed as it is called. So essentially, if the angle is over a threshold that we have set here, then we need to continue accelerating up into our max speed. If we're closer than 30 degrees to the final overshoot, then we are decelerating. Either way, we're rotating towards a target. So then, as we're moving that rotation, we're passing in our acceleration and deceleration. Here they actually just happen to be the same, but they are parameterized so we can put in whatever values or variables that we want in the future. We pass in our maximum speed as well, and then that allows us to rotate smoothly. If we haven't opened our claw and we're within 50 degrees of the target's completion, which would be 20 degrees before the player direction, we can open the claw and throw the container, and then just make sure we're not going to do it more than once. So opening the claw is very simple, just like closing the claw. We essentially just track a Boolean, set a trigger, and wait for the animation event to flip it back. Throwing the container is as simple as getting the transform, setting its parent back to its original, and setting the rigid body back to dynamic. Then we can set a velocity that we've set based off of the direction from the carriage to the player, and our velocity that we're throwing the object. We also add a little bit of random angular velocity here, just to make things look a little bit more natural. And when the object is being thrown, we turn on a collider that's specifically for damage. So there's two colliders on the object. One is just for damaging, and one is for detecting what can be picked up. So it ends up being relatively simple at the end of the day, with some pretty cool effects. So let's look at some of the components. Our crane controller has a crane top and a crane bottom. The bottom isn't really used for anything other than visuals. The crane's top is actually what we're using for the crane's arm, as far as the script is concerned. The carriage transform is the actual carriage where the claw is connected. We're just using the default layer mask for our container because we're only really concerned with objects that implement our interface. We have some rotation speeds and a throw rotation speed set, and how fast we're going to throw the container, how fast the carriage can move along this arm, the animator that we're setting for the claw to open and close, which is very simple. We really just have an idle, empty animation, an open and close that just set a sprite and then call the animation event. So on each one of those, we have a simple script, crane claw animation event, and all it's doing is just setting up a simple delegate to call a Unity event so that we can assign these in the inspector to call our functions back on the crane object. So that's how everything's set up there. So this allows us to detect anything that has the iThrowable interface on it. So if we look at a throwable container, it implements throwable, which is each one of these functions. Rigid body just returns the reference to the rigid body. We have a pickup collider and a collider for our actual damaging collider, and a simple get transform function. We have the set velocity function that we used earlier, which simply sets the linear velocity and angular velocity. How much simpler can you get there, really? So then all that comes together to create this cool effect. And I think it's awesome. I'm going to tweak it a little bit more and just, add a few extra mechanics. Like, I think we should be able to shoot these containers while they're being thrown. Perhaps I might make it so that there's an effect when the containers get picked up so that they look slightly visibly different. but they're definitely effective. I'm definitely getting killed by them, so I think it'll be pretty fun. Well, I hope that was useful for someone, and I think it's really cool. I can't wait to actually get it into the game and to finish up the second phase of this boss. Hope you guys enjoyed the video. Every like and subscribe definitely helps me out because I'm new to YouTube, so hit those, and I'll see you next time. Thanks.